Artificial intelligence makes difference research in school mathematics more relevant. Alan Tarp, mathacademy.net, Denmark. With comments from Olive Chapman, University of Calgary, Canada. Calculus, add stacks in primary school, and poor numbers, in middle and high school. Artificial intelligence, AI. Artificial intelligence is the opposite of natural intelligence. It comes from Latin, intelligere, meaning thinking, before choosing. Programming languages instruct artificial brains how to make intelligent repetition and choice. Repeat. Until allows stopping after thinking. If, then, allows choosing a different action after thinking. Artificial intelligence drastically improves human productivity by creating artificial humans, robots, or AI bots. This is great, or is it? The three grand risks: nuclear war, pandemics, and artificial intelligence. In late May 2023, 350 leading scientists and notable figures signed a common statement saying that mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war. YouTube video, AI and the Future of Humanity, by Yuval Noah Harari, at the Frontiers Forum, May 2023. By its ability to develop itself, AI may soon change from artificial to alien intelligence, able to hack and infiltrate human language and text. Our prime tool for a democratic, interhuman cooperation, based on information, debate, and voting, now may be infiltrated by an alien intelligence that may supply fake information and seducing arguments to influence the debate. So, we ask, how to protect mathematics and its education and research from being infiltrated by alien intelligence? This task seems almost impossible, since both mathematics and education and research is text-based. So, this leads on to the question: can mathematics and its education and research exist in a text-free version? But, the goal of math education, is it well defined? What comes first, to master math, or to master many? All say, the goal is to master math, to later master many. But math is hard. Why not first master many, to later master math? So we may ask, what mathematics may grow from children's innate mastery of many, as developed before school? Kids use units, 2 3s, schools don't. So math differs, inside and outside, the no-unit math greenhouse. Inside the no-unit math greenhouse, 2 + 1 is 3, always. This is mathematism, true inside, but seldom outside. Outside, we use many math. Asking 2 + 1 is what? The answer depends on the units. 2 weeks + 1 day is 15 days. 2 meter + 1 meter is 3 meter. 2 kilometer + 1 millimeter is 2 kilometer. $20 + 10% is $22. 2 + 3 is 5 sometimes, but 2 times 3 is 6 always. Why? Because here, 3 is the unit. We ask the three grand theories. First we ask, how to make mathematics text-bound. Philosophy says, choose essence over existence. Psychology says, choose Vygotsky over Piaget. Sociology says, choose means over goals. Then we ask, how to make mathematics text-free. All three say, choose the opposite. So, to make mathematics text-free. With philosophy we choose existentialism over Platonism. With psychology we choose radical over social constructivism. With sociology we choose individuals over institutions. A text-free mathematics, out of the reach of AI. Recommendations from the three grand theories. Philosophy says, focus on outside existence, be skeptical and flexible when choosing inside essence. Psychology says, develop the learning coming from meeting and adapting to outside existence, as described by Piaget. Sociology says, avoid a goal displacement, making mathematics a goal instead of a means. And return to the original Greek goal, to study many as it exists, in time and space. Difference research and demodeling may help. Guidance may come from difference research, that search for differences making a difference, by constantly asking, can this be different, when looking at the core of mathematics? And from postmodern deconstruction, using demodeling to find outside concrete examples, to root inside abstractions. The core of mathematics is seen on a basic calculator. Single and multiple digits, operations, and equations. So, the task now is demodel core mathematics, as things in space, and actions in time. Demodeling digits as icons. The tradition says, digits are abstract symbols, outside time and space. A difference says, 5 is an icon created in time by uniting 5 ones into one 5 icon, thus containing as many sticks, as it represents. Likewise with the other digits, until the number 10, that needs no digit, if used as a bundle unit. Collecting 10 sticks into one bundle leaves no sticks. So we have, not one number, but two numberings, of bundles and of unbundled, 10 is one bundle 0. Thus, we need no place value system. Demodeling digits with units. With 3 as a bundle unit, 9 becomes a bundle of bundles, and BB is B to the power 2. With 2 as a bundle unit, 8 becomes a bundle of bundles, and BBB is B to the power 3, thus introducing power, as the first operation. Rolling 2 dices, we may say 2 threes, which shows that digits are needed both as unit numbers in space, and as counting numbers in time. By itself, a digit is not a number, but an operator needing a number to become a number, as show when writing numbers out fully as polynomials, as they are spoken. 345 is 3 times 100, plus 4 times 10, plus 5 times 1. The number sequence is typically learned by memorizing a row of names, as when memorizing the names of the months. This could be demodeled by always including the units, and say 0 bundle 6 instead of 6, and 3 bundle 4 instead of 34, and 6 bundle, 7 bundle, 8, instead of 678. Demodeling the unbundled. With snap cubes, the unbundled may be placed on top of the stack, seen as a decimal number. Or with a negative less number, counting what is needed for another full bundle, an underload. Counted in twos, a total of 9 may be written as a flexible bundle number with units in 3 ways, normal, and with underload, and with overload, with no carrying, which eases standard operations. 9 is 4 bundle 1, or 5 bundles less 1, or 3 bundle 3 twos.
Flexible bundle numbers ease operations, when using overloads, and underloads. Counting in tens, 74 is 7 bundle 4, which is 6 bundle 14, which is 8 bundle less 6. With addition, 74 plus 18 is 7 bundle 4, plus 1 bundle 8, which is 8 bundle 12, with overload, and 9 bundle 2 without, thus giving 92. Likewise with subtraction, and multiplication. With counting or division, we write 33 bundle 7 with an overload as 28 bundle 56, that counted in sevens gives 4 bundle 8, or 48. So, with overloads and underloads, we don't need to carry or borrow.
Demodeling operations changes their order. As counting actions in time, the order of the operations is the opposite. Power is rooted in bundle of bundles. Division is rooted in pushing away bundles. Multiplication is rooted in lifting bundles into a stack. Subtraction is rooted in pulling away the stack to look for unbundled. Addition is rooted in uniting stacks next to or on top. Seeing operations as actions leads directly to the core proportionality formula, used to change units, saying that the total T contains T over BBs. This recount formula is used all over science and STEM.
Divide and multiply and subtract and add, may be demodeled as icons, also. From 9, push away 4s, we write 9 over 4, iconizing a broom, called division. 2 times lift the 4s to a stack, we write 2 cross 4, iconizing a lift, called multiplication. From 9, pull away 2 4s to find unbundled, we write 9, pull away 2 times 4, iconizing a rope, called subtraction. Uniting next to, or on top, we write b plus c, iconizing the two directions, called addition.
Recounting from icons to tens, gives the multiplication tables. Recounting from tens to icons, solves equations. Asking, 6 times 7 is how many tens? 6 times 7 is seen as 6 sevens or as, bundle less 4, times, bundle less 3, on a 10 by 10 bundle board, ABB board. This is early algebra. Asking how many 4s in 20, leads to the equation u times 4 is 20, solved by u equals 20 over 4, since 20 recounts in 4s as 20 over 4, 4 4s, or as 20 over 4, times 4. Likewise, the equation u plus 2 is 5 is solved by moving over, as u equals 5, take away 2, since u is a placeholder for a number that, with 2 added, gives 5, that of course is found by reversing the action, and pull away the 2 again. Solving equations by the two opposite side with opposite sign method, is a difference to the traditional balancing method, do the same to both sides, introduced to motivate teaching teachers about the abstract algebra concept, group. Recounting creates per numbers, becoming fractions, with like units. Recounting the same total in 2 units gives a per number as $5 per 4 kilograms, that becomes a fraction with like units, $2 per $5 equals 2 per 5. The per number bridges the 2 units by recounting. 20 kilograms is 20 over 4, times 4 kilograms, which is 20 over 4 times $5, or $25. Per numbers and fractions are operators, not numbers. Recounting the sides in a rectangle split by its diagonal leads to trigonometry before geometry. Height is, height over base, times base, or tangent of angle, times base. Addition comes last, but on top, or next to. Adding on top leads directly to proportionality, using the recount formula to make the units like. Adding on top means adding as areas, called integral calculus, and differential calculus when reversed. Before adding, per numbers must be multiplied to unit numbers, thus also adding by areas. Demodeled, calculus thus occurs 3 times. In primary school, as next to addition of stacks. In middle school, as adding per numbers, that are piecewise constant. In high school, as adding per numbers, that are locally constant.
There are 4 ways to unite, or to split a total. A number formula t equals 345 equals 3 bundle 4 bundle 5 is called a polynomial. It shows the 4 ways to unite, addition, multiplication, power, and next to block addition, also called integration. Addition and multiplication unite changing and constant unit numbers. Integration and power unite changing and constant pair numbers. We might call this beautiful simplicity the algebra square, since in Arabic, algebra means to reunite. The 4 uniting operations each has a reverse splitting operation. Addition has subtraction, and multiplication has division. Power has the factor finding root, and the factor counting logarithm. Integration has pair number finding, also called differentiation. Reversing operations means solving equations, done by moving to opposite side, with opposite calculation sign.
Fact and fiction and fake, the 3 modeling genres. With mathematics a number language describing outside things in space, and actions in time, its quantitative literature, or models, needs to be divided into fact, fiction, or fake, the same genres that exist, when using the word language to produce qualitative literature. Fact stories are since then stories, that quantify and predict predictable quantities, by using factual numbers and formulas. They need to be checked for correctness, and units. Fiction stories are if-then stories, that quantify and predict unpredictable quantities, by using assumed numbers and formulas. They need to be supplied with scenarios, building on alternative assumptions. Fake or fiddle stories are what-then stories, that quantify and predict unpredictable qualities by using fake numbers and formulas. They need to be replaced by word stories. Teacher education, ask the subject, not the instructor. Typically, teacher education sees mathematics as a timeless self-referring body of knowledge, that supplies school mathematics with a theoretical background, to be pedagogically supplied with real-world examples, as the sugar that makes the pill go down. As a difference, Demodeling instead presents mathematics as things and actions in time and space. The things may be found on a 10 by 10 bundle board with rubber bands, to show different stacks and forms, and the actions may be describing totals, by counting and adding in time and space. A corresponding teacher education may be found on mathacademy.net. That offers a text-free, action-based education in many math by saying, let kids teach teachers teach mathematics as many math, a natural science about many, using flexible bundle numbers with units, to count and recount, before adding on top and next to, the CATS approach, count and add, in time and space. The material is self-instructing since, when in doubt, you just ask the concrete subject, not the instructor.
There are 8 competencies inside the no-unit greenhouse, but only 2 competencies outside the greenhouse. To master many, first you bundle count and recount, then you add.
Demodeling research, review the reviewers. Typically, research papers are reviewed by peers, without allowing the author to review the reviews. With AI's ability to create research papers itself, the time may have come to allow this, on the base of the genre conditions, question, method, design, data collection and analysis, finding, discussion. And maybe reviewers should have their own papers rejected, if they don't follow this. Also, a salon de refusee should be included to conferences to give an indication of what is accepted, and what is not. Art developed from rejected works demonstrating difference. So, to create a text-free version, out of the reach of artificial intelligence, mathematics could retake its original Greek goal, as a natural science about many, and stay as the human number language about many, that children develop before school. Conclusion: yes, we can protect mathematics and its education and research from AI. We asked, can mathematics and its education and research exist in a text-free version? Inspired by the recommendations of the 3 grand theories, and guided by difference research and postmodern demodeling, we have found that, to create a text-free version out of the reach of artificial intelligence, mathematics could retake its original Greek goal, as a natural science about many, and thus stay as the human number language about many, that children develop before school.
A final question. In the United Nations 17 Sustainable Development Goals, number 4 is about quality education. Should ethical quality education force children to enter inside a no-unit math greenhouse that slowly strangles their innate number language by using line numbers to learn no-unit addition that folds outside? Where children's innate mastery of many just waits to be developed by flexible bundle numbers available at their fingertips.
Theoretical background. Mastering many, by counting and recounting, before adding on top and next to. Journal of Math Education. Demodeling numbers, operations, and equations. From inside to outside understanding. Ho Chi Minh City University of Education. Flexible bundle numbers develop the child's innate mastery of many. Workshop. YouTube video. Woke math never forces fixed forms upon flexible totals. Other Mr. Al Tarp YouTube videos. Artificial intelligence makes difference research in school mathematics more relevant. Thank you for watching.